Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good evening. I'm Lieutenant Abdul bin Abdul Majid TLDM. My supervisor is Dr. T.S. Muhammad Abu Ubaidah Hamid bin Abdul Zalim and my co-supervisor is Lieutenant Commander IRTS Muhammad Najib and also Lieutenant Commander Muhammad Azri. Today I will present my proposal on master project, which is a modification on cooling system fin stabilizer. In this project, I am focusing more towards on modification, uh, which more towards on engineering side. Before I go deep to my project, here is a content for the research proposal, which includes the abstract, introduction, problem statement, research question, research objective, scope of my study, limitation to my project, and proposal, research methodology, literature review, contribution to my master, and also my last is a reference. Here, before I go to my detail, I want to show all of you my methodology. Start for this project. Firstly, I want to understand on literature review. This literature review is focused more on the fin stabilizer and also the problem that happened to the system. Then after I understand the operational and the function of the fin stabilizer, I go to the collecting data. The collecting data is very important to understand before and after to get when they get the result. Firstly, I must get the operating reading sheet from the staff to get the reading on the temperature, on the flow rate of the cooling system. Then I want to make sure that my project is based on this fin stabilizer. I want to get the factor acceptance test as my guideline FAT to ensure that my reading is not burst and also not over to the limit. And lastly, my reference is I want to make sure it's based on the technical manual. After the collecting data, then I go to the physical inspection. Why physical inspection? Because to ensure that the system running in good condition, and then from the when the system is running, one must to get the reading on the pressure from the gauge and also the temperature when running, and the system will be running for 1 hour. And lastly, after we get the reading, I will check on the condition of the piping to ensure that no clog and also no dissipation on the system. Then after I get all the data, I go to the calculation. Why calculation? Because to make sure that the defect to the fin stabilizer cooling system because of what? Then we make a calculation based on the FAT on the technical data to ensure that input and output of the cooling system, it should be as a what they get. This means I will calculate the duct pressure and also heat transfer. Then after all this calculation have been done, we go to deep on a design and also analysis. Why? Because we want to get the best design and also any option that we need to give. And lastly, we make analysis, and also from all the steps we make a documentation. Okay, firstly, we must understand this fish stabilizer is designed by Bloom Voss Industry, and the model of this type is a FK. Why FK? Because first it's fitted with anti-vortex. While fitted with anti-vortex tip fairing to prevent energy dissipating vortex gravitation, actually this design is slightly same as an aeroplane fin to ensure that not any uh, next is a mounting frame is accurately shaped to the feet of the hull line, and lastly the this type of fin stabilizer is independent lock system which keep its neutral position by hydraulic, mechanical lock or mechanical locking. Next, we go on the technical data. Based on the technical data, we focus more on the cooling part. As you can see, this is a cooling part of the system. The cooling capacity is 20 kilowatt. Cooling medium water. For this equipment, we are using a seawater cooling system. The flow rate for this system is 10 meter cube per hour. Water pressure is 2.5 bar, and cooling water inlet temperature is at 38 degrees Celsius. This 38 degrees Celsius is based on the FAT acceptance. Next, before we go on on the project, we must understand on the literature review. For this project, we focus more on three calculation, which is a first law of thermodynamics, Q equal to mc, and also heat dissipation of a heat exchanger. Flow rate, focus more on water flow, and lastly on a pressure pump. Heat will affect the temperature. The flow rate, as I said before, we focus back to the uh, flow rate of the water, and lastly pressure. We go to the project. Okay, the spin stabilizer of the ship used for helicopter landing and weapon. It used for damping the rolling motion of the ship at the rough sea if happen. The operational for this fin stabilizer is separated by two, which means first is for electrical part and also a mechanical part. On this part, we focus more towards on the mechanical part. As you all know, this fin stabilizer is very important, especially for the warship, especially for the when weapon, or using for the weapon to get accurate reading. Alright, what actually happened to the fin stabilizer? This fin stabilizer, when it's running the operational, can cause until 60 Celsius of temperature, which means the maximum highest of temperature which can cut off the system. Because of that, uh, we suspect of the size of the cooling pipe, because this fin stabilizer is operate consists of uh, CPP, stern tube, and also ECU system. That's why, to overcome this problem, as I said before, we have to check back uh, on the calculation requirement, also the physical inspection, and also make analysis to overcome the problem, to ensure that the system can operate at a consistent temperature. As I said before, this phase stabilizer is separated by two, part A and part B. Part A focus more on a mechanical side, part B focus to the electrical side. Okay, this is a layout for the system piping. As you see, the arrow of the from the sea chest of the seawater goes into the pipeline, and then separate to the this line is a for the ACU system. This one is for the CPP system, and also this one for the fin stabilizer system. This one consists of one system of one line cover for three system. Problem happen. Why I want to do this research? Because of during the running system, seawater supply to the pump to the fin stabilizer suspected to be sufficient pressure and flow rate. Because of this issue, the temperature goes high until more than 60 Celsius, and because of that, the pipe and the pump supplies for the cooling system is not suitable, because the problem happen when all systems are running. That's why, because of one line cover for three systems. For the research question is the current flow rate and pressure cooling system sufficient for the operation of the fin stabilizer? Second, does the size of the piping can cover the whole system? And lastly, how to effective analysis the cooling system? On this stage, we will suggest a few system to ensure that the system can operate normally. Then from that, the objective is come up with to analyze the flow rate based on pressure by calculation. This is based on calculation, and then optimize design of the piping. This one, from the calculation, we come up with the solution, and lastly analyze the cooling system using a specific method to approve the system. This one we are using a software to get the result. Okay, scope of this study actually focus on modification of the piping system to get a good flow rate and a pressure to ensure that the temperature can constant when the operation is running. And then what we get is a limitation of this project to analyze using the software, because this type of software is not all industry using, only a few industry are using this. And then the data collection based on the operational reading, and we get, and also lastly is this project is focusing on the support system for the main fin stabilizer. Therefore, research and development mostly are upgrading the equipment. This means we are not focusing on the system of the fin stabilizer, but actually we are focused on the support system of the fin stabilizer, which is a cooling system. Alright, after we get all the data, we get all the analysis, and we get all the suggestion, then we come up with the solution and expected solution for this project. As you can see, this is a graph before. This one is before, and this one is after. Before, we running is only 1 hour, but after 30 minutes before the modification happen, they will cut off about less than 30 minutes. But after the modification happen, we will ensure that the temperature will sustain with almost about 40 plus Celsius. Why 30 degrees? Because we based on Malaysian condition water. That's why this fin stabilizer continue operating if without changing the system, because if we want to change the system, it can costly time, and also it can cost the high process of modification. But because we are focusing on piping, the cost for the system is very low. And also it can give positive effect to the Kasturi, because the Kasturi also have same problem on this issue. That's all for my presentation. These are all about my reference. We are focusing on first is on technical manual, and then para 2 and para 3 focus on theory, and then fluid power for the para 4 focus on the fluid power, and lastly introduction of theory of fluid. That's all for my presentation. Thank you.